So I have a scenario. Two individuals walked into a car dealership. One is wearing some, ragged looking clothes, driving a old beat up car. Another one is wearing a suit and driving a Lexus. By a show of hands, how many of you guys would approach the person who's not dressed in the suit? Okay, so it just tells me that the remainder of you would approach the guy in the suit. That's perception, right? Because your perception is what you saw. The way the guy is dressed, he's the one with the money, but he may not be, right? Perception is the way we see our world and how we interpret it. So this is an overview of the presentation. Basically give you a summary of the weather technology in the cockpit and the AWRP or Aviation Research Program. Look at the problem, and then we look at changes in weather, research, perception, and then we're going to review, Danny, my colleague, is going to review a few accidents. And then, of course, we're going to wrap it up. So these are the two programs that the FAA has, Weather Technology in the Cockpit. I'm with the Weather Technology in the Cockpit, and Danny is with AWRP. We're two research programs. And we don't have enough time to tell you much about the programs right now, but we're in the FAA hangar, so you can come and see us if you need any more information on the programs. So there's always a problem, right? So here is the problem. These are stats that we pulled directly from NTSB, so we didn't make this up. VFR and IMC accidents are still up. And the next slide I'll show, you'll see that it's not just VFR pilots. Here is the next slide. So when we go to do these presentations, most people think that it's only VFR pilots, or these guys, they don't know what they're doing. But it's not VFR pilots too. If you're IFR pilot, you're IFR rated, but you're not IFR current and proficient, you can find yourself in that situation. And these are stats that came out in the null report, which is produced by AOPA. This is a study that was done by Embry-Riddle Aeronautical University in Daytona Beach, and it was funded by the FAA, and here are some of the contributing factors. Lack of aviation weather knowledge and skills. As instructors, I would suggest that every time you take your student out on a flight, it doesn't matter if it's local, you ask them to look at the weather, and you ask them to explain to you what they looked at and how they interpret that information. It will help them in the long run as they progress in the aviation career. Weather technology and products usability, right? There are a lot of products out there. Some of you have probably used them before, but they all have capabilities and limitations, and so do you. And most people are not aware of that. Conflicting and outdated pilot resources, there are a lot of that. And of course, poor decision making and limited weather training. So a lot of the products sometimes out there, or most of the displays that you see, whether you're buying a Garmin or whatever you're using, most of the time there's not a whole lot of training that goes into how you use a system, how you use the application. It's more about the buttonology. Here is some more information that came out of that study. Found that pilots have difficulty interpreting weather products. And this is the big kicker here. So everyone know you need a 70% to pass the written exam, right? So a lot of these guys failed. And we have the final report. We have more data if you guys need it. All right, so going into the research. So this here is a change in weather. This is the weather research that we did at the Atlantic City Technical Center. I'm an engineering psychologist. I'm a human factors lead, but I'm also a pilot, so I see it from both angles. And we did this study. We looked at 3 different presentations of weather information on the glass, and we had pilots fly them, and we collected data. What we found when the airports changed from VFR to IFR, pilots were not aware of it because there's something called change blindness. The symbology changed, but they weren't cognizant, and they continued flying. So we figure out, well, maybe the symbol is not bright enough or salient, so we added some, made it a bit brighter. That helped a little, and then we tried using other methods similar to having a tablet and color coded VFR, IFR, etc. And then we used the wristband, which vibrated. So when the symbol changed on your display, the wristband vibrated, which gives you a tactile notification, and you look at the display and see, okay, something changed. That worked a little, but we needed to get the vibration right. But these are all experimental stuff that we're trying. Most of you are probably aware of ASRS, Aviation Safety Reporting System. It's a get out of jail card. You commit an incident or infraction, you call up and you give them a report, and then the FAA doesn't come after you. So we had them do 100 callbacks. Basically, we're trying to get data on what are some of the problems that pilots are having, because these are guys that had an incident and this. You gotta give me back some more time. Yeah. So they had an incident and they reported it. And as a result of that, they were able to call them back and get some more clarification on what happened. And we were looking for things like, well, was it the information that they were looking at that they interpreted incorrectly? Were they talking to flight service station, or who they were conversing with to try to get a sense? Was it equipment malfunction or something like that? And so we got that, and you'd be surprised what you actually saw when you read the report. All right. So we get the perception of why it's important, right? And what is perception, right? Like I said earlier, is the way we see our world. We look at the information out there and we try to organize it to make sense of it. It's important, right? Because that's how we see the world, right? And my perception and your perception is a little different. I'm not going to read everything. All I can say, that perception is a cornerstone of decision making. And for pilots, decision making is a very important piece if you want to be safe. Perception and situation awareness go hand in hand, and I'm not going to explain what situation awareness is, because if you're a flight instructor, you don't know what that means, then I'm not sure I can help you with that. Maintaining situation awareness is a continuous process. Okay, you need to, when I was flying, my instructor always told me, Ian, you need to be cognizant of what the airplane is doing at all times. So that's part of situation awareness. If you're VFR pilot, you need to look out the window to ensure that you can see the other airplanes around you so you could be safe. But it's very important, so that's why this is a continuous process. And a lot of this information came out from the risk management handbook, so I didn't make this up. It's a free handbook that you can download from the FAA website. All right. Some of you probably have never seen this before, but these are all things that influence a person's perception. Your culture could influence your perception, your values, your notions, and your experience. And if you want to talk about experience, right, how it affects a person's perception, people make decisions sometimes based on experience. For instance, if you had a bad experience, you probably remember it and you alter your behavior the next time. If you had a good experience, you'll probably remember it too. So, and of course, beliefs. So all of these things here, influence a person's perception. And there's always a process, right? So how we think, top and bottom up, influence the perception. And so for the top down, you have perception, you have knowledge, mental models, past experiences, as I said earlier, expectations, training, and then at bottom up, external cues. We're talking about like weather and everything outside of the cockpit, communications, and of course, information displays and products. Influences of pilot perception. I have a diagram here to add some more information to that. See, we have knowledge again and training. We break it down. And then when we go to weather products, you see we have the various weather products that pilots use, like NextRed and AirMets, SIGMETs, and TAFs and stuff like that. And this is just to break it down to show the factors of risk perception. And, you have the cognitive and contextual and individual factors and how they all come into play. And then there's the risk assessment matrix on the side. And then I actually pinpoint two areas there, the contextual and information, individual training, factors rather. All right, so I now turn this over to Danny, and he is gonna go through a few accidents that actually allude to what I'm talking about. Then I'll come back and wrap it up. Thank you.
All right, thank you, Ian. Yeah, now let's look at some real examples of what we're talking about. Perception versus reality, and how even in the clear indication of hazards, how one's perception can influence their decisions. So the first one we're going to look at here what was a flight from Central Florida intending to go up to Clemson, South Carolina. A very experienced pilot, airline transport certification. And this accident happened in the morning time, so you're not immune as far as time of day. So let's go in and just look at some more information based off of this particular event. And as I noted on that slide, these are real real accidents, NTSB investigations into those. So they're available from the NTSB site also if you want to look into these in a little bit more. And I'm just trying to hit some of the highlights from the weather perspective itself. As I said, leaving from South Central Florida, basically a straight shot north up to Clemson, South Carolina was what was intended. If you look at the surface analysis for that day, there's a front laying across northern Florida. And why I point this out is just from a pre-flight planning process, if you're going to be going across a front or in the vicinity of front, automatically it should be a heads up to you. A lot of accidents happen in the vicinity of frontal zones, happen in the vicinity of low pressure centers, because that's where hazardous weather often occurs. It's not confined to those areas, but again, if you see yourself coming across somewhere like that, you've got an excellent chance of encountering some type of weather, so be aware of it. This is a product that's put out by NOAA's Storm Prediction Center, the SPC. This product is really geared towards severe weather. Severe weather from the Weather Service standpoint, tornadic activity, large hail, very damaging winds are some of their indications. So as aviators, though, whether it's severe or whether it's not really is kind of irrelevant. It's a thunderstorm, and it's something we need to be aware of. But what I want to point out here is that you look across Central Florida, there's this dark green area of a marginal risk of severe thunderstorms. These forecasters that put these products out, they are, I'll tell you, they're good. They're good. It's a 24-hour product, so you're not going to know when the thunderstorms are going to happen, but they usually have a pretty good grasp on where the bad weather is really going to break out. But the light green areas are areas of non-severe but still thunderstorm activity can be expected. So right away, what we've seen in this situation, just from looking at a few things, is you're going to be going across a frontal zone. Heads up, there could be weather. There's a very good indication of thunderstorms and severe thunderstorms that are going to be along this route of flight. That morning already, 10:55 Zulu, 4-hour time difference. You're talking 6 a.m. 6:55 in the morning. There's a convective sigmet that's already out for convection in that area going across Florida itself. And if you look up at the upper top there, the last bit of verbiage is an area of thunderstorms moving from 250 at 30 knots. These thunderstorms are moving very rapidly with tops above flight level 450. 2 hours later, an updated convective sigmet comes out. It's still across that area. Thunderstorms are there. They're expected to continue. And then if you look down at the bottom three lines on this one on the left, it's now changed from thunderstorms to severe thunderstorms. Early in the morning, and these thunderstorms are getting stronger, all right? Should be an indication that, hey, something's up. Let me take a look and see what might be some options here. Well, our pilot takes off. He's the one in the middle of the screen, N155CL. That's his location around 1849. There's another aircraft that went up there, up the left part, that actually went through and tried on the back side of this weather, and as they were going into Gainesville, they made it in. All right, really by the skin of the teeth. They just gave some comments of we got rocked. Okay, no other way to put it. We hit a pretty good downdraft. It got pretty rough there for a minute, and they got on the ground. And I was just thinking about something that Ian said. Perceptions are made based on your experience. And so oftentimes we hear about, oh, I got through there that time. Yeah, it was pretty rough, but I got through. Maybe it's not as bad as what everybody is saying. Actually, when I look at this, I thought that one up the upper left was probably the one that got into the accident, but it's not. Anyway, at this time, the pilot told ATC, who had informed him that there's an area of heavy to extreme precipitation about 60 miles ahead. The pilot says, well, if it gets worse, I'll turn south and I'll put down at Ocala and I'll wait out. Excellent plan, an excellent plan. He was thinking about what might happen. But I'm kind of confused by if things got worse. How much worse can it get than that line right there and those reflectivities themselves? All right, a few minutes later, he's continuing on. Situation hasn't really changed too much. Continuing on at 8:57, the pilot asks about the weather, and ATC says heavy to extreme is still ahead. And ATC starts vectoring the pilot 10 degrees left, trying to maybe get towards a hole to avoid the heavy to extreme precipitation. And at this time, the pilot, most likely based on his perception, and I'm not sure why or whatever, said, I see an area 40 degrees to the right that looks good, and I think I can get through there. Yeah. I've heard from others whenever I talked about this, you're doomed, all right? You're doomed. So, pilot goes that way rather than taking the advice of ATC. He gets in the clouds. He says, that's pretty smooth. I got some lightning off to the right. And that was the last communication we had as this pilot goes straight into what's one of the strongest parts of the storm itself as it's moving again from the northwest, moving towards the southeast. It's moving, got a good easterly component that's moving there. But into the strongest area. Other radar information at this time basically showed he flew right into a tornadic activity that was in the storm. We lost contact at that time. All those black dots up there aren't scattered remains from the aircraft itself, they're lightning strikes. Over the 20-minute period from 8:55 to 9:15 local time, over 4,000 lightning strikes were recorded with this storm. Very active, very strong storm. Again, if it gets worse, I'll turn back. How much worse does it have to be? Well, this is ground-based radar, okay? What was the pilot maybe seeing up in his cockpit? This is what was available through FSB. We don't know if the pilot was looking at this or not. The NTSB just cannot determine that, but as you can see, as we just click through this real briefly, the picture is still painted. This is pretty bad. Again, we're talking perception versus reality. What drove the pilot to do this? And, to no surprise, you can see this probably isn't very surprising at all. It's not very good to look at. We don't like to do that. But this is what happens. When your perception influences you to the point that it overrides everything else that's being talked about here. So, what did we have about this? Again, there was a line of weather 60 miles north, heavy to extreme precipitation. Pilot knew this. Okay, there's no doubt that he was aware of this. It was communicated. He acknowledged it and said he could turn around and wait it out. He saw an area that looked good to his eyes, perception, based off of what? And he gets in, it's just like initially, oh, it's pretty smooth. It's not too bad in here. But that's not what the outcome was. So just some thunderstorm do's and don'ts. And let me just highlight some of the ones. First one up in our column on the left here, avoid them. Avoid thunderstorms. I mean, that's the best policy. There it is. Data link NextRad coming up to the cockpit. I think a lot of you know that there's latency on it. It shows where the weather was, not where it is right now, where it was, and definitely not where it's going to be. Do not use that as a tactical tool for avoidance. All right? Great tool, has its good uses. And then divert and wait on the ground. All right? Our second case. This is a VFR flight. A pilot who not as experienced, happens in the evening, unfortunately 2 fatalities. He's going from Gulf Shores, Alabama on the Gulf Coast, going to be heading again pretty due north up to Muscle Shoals, Alabama. And let me see what else I want to put on there. Again, general thunderstorms are forecasted, not severe. A little bit of information about this pilot, all right? At his last review 1 year prior, the pilot himself says he was a bit rusty. He had not flown a lot lately, and the reviewer emphasized to use a checklist also. He really emphasized that to him because the pilot had a tendency to do things from his memory. But the pilot was characterized as not being a risk taker. And he stated, if I can't get somewhere VFR, then I don't go. And I hear that from a lot of pilots. I really do. And it's good. You know your limitations. You know what you're comfortable with. You know what your aircraft's comfortable with. And that's just what he stated. But there was some perception, I think, as you can guess, because I'm showing this as a case, he ended up going against everything that he had set before, all right? And we'll get into maybe why that was so. So again, I showed that flight route. Here's the SPC product showing that thunderstorms are possible. This was the radar composite that would have been available to him at a weather briefing, 16:15 local time. There's a lot of convective activity spread out through there. It's what you see in the southeast United States on days like this. It's hot, humid, thunderstorms pop up. Maybe you can navigate around through there, but there's some pretty good areas of precipitation that are filled in. You know, the likelihood of this being a completely VFR flight, just from looking at here, is not high. So the pilot started asking about, what about the next day? The briefer said, well, it doesn't look very good. VFR not recommended. And so the pilot said, well, maybe I should go today. What do you think? And the pilot said, or not the pilot, but the briefer said, well, things they're starting to get down. The clouds are starting to get down pretty close to VFR, and we're not expecting things to improve. So we looked at a couple graphical weather products from aviationweather.gov. Here's the one that's showing thunderstorm activity and rain shower activity throughout the area. We look at the ceiling and visibility, or the clouds themselves. There's a lot of clouds just to the west of where he is over in Mississippi, and so in his area in Alabama, not as quite widespread coverage, but remember the briefer said they're starting to drop. Things are getting worse. Well, the pilot's sitting, all right? The pilot is sitting at the airport, and it's pouring down rain on this particular day. It's raining hard. And at one point, the pilot actually unloads his plane, but then decides to load it up again. And then he takes off at 18:45 local time. All right. And these are just some of the METARs as we go through. And I've highlighted the visibility, the weather, and the cloud conditions. And you can see conditions indeed were bad. 2 statute miles at 1735, ceiling at 32. 20 minutes later, new METAR, 2.5 miles, heavy rain still, and the ceiling's down to 1600 now. And at 1815, it keeps dropping. It gets even worse. And then at 1835, conditions improved somewhat. Now, we don't know what the pilot was thinking, and there's always danger in speculating, but there's a slight improvement, and you're no longer, you're over 3 miles visibility. Your ceiling has increased, and the pilot 10 minutes later departs. Perception is we oftentimes look at our departure and our arrival locations and don't take into account everything that's going on en route. Yes, conditions had improved at departure, but not necessarily elsewhere. All right, as I said, the pilot took off at 1845, turns to the left, climbing to 3,000 feet. You can see these, the blue lines are the aircraft track itself. At 1845, he turns left 90 degrees, descends slightly, it descends down to 2,500. ATC at this time asks if you need any help because there's weather to the north. There's a cell to the north, and there's no response that he gets. At 1855, the pilot then says, hey, I'm trying to get through some clouds here. And ATC advised, head west. All right? This is the way to do it. The pilot acknowledged that direction to head west, but for some reason, the pilot then turns north and continues on, even though ATC advises heavy to extreme precipitation and gets no response. And then at 1859, we saw the 360-degree turn there, and then the track becomes very, very erratic. The altitude starts descending. Ground speed starts varying between 150 and 34 knots, and this is the last position that we see. I do not, the question was ATC approach or center control? I don't know that answer off the top of my head. I could go back into the report and look. I really don't know. Yeah. This is the surface weather radar from the Mobile, Alabama National Weather Service site, and we see you can have the flight tracks. Yeah, departing at 1845, you can see the heaviest weather has gone through. You're in some green and some blue areas. Conditions are indeed improving at Gulf Shores where this pilot happened to take off. He's heading north, and weather's looking good, but we can see here what's waiting ahead. This is 1851, before the pilot made that left-hand turn. 1857, after turning to the right, or turning to the north then. And this is actually 1902, not 0902. But this is what we see 2 minutes after the last position that we had. This aircraft went down with the pilot and their spouse on board. And unfortunately, this is all that remained of that. And so what we see from this, perception versus reality, that's our talk here. I'm not a risk taker. If it's not VFR, I don't fly. But the pilot was rusty. As Ian mentioned before, you may be qualified but not proficient. And so I think there was some of that in there. Use a checklist. Don't just go off, what you've heard. And again, I don't fly in these situations, but this pilot did. And was it because he had a business meeting the following day? The get there itis can overrule everything that you've seen based off your perceptions. So just some things to remember. Check all observational sources for areas around your flight, not just the METAR, and not just the METAR and the TAPs at where you're departing from and where you're arriving into. We know from the studies that even Ian mentioned, pilots struggle at depicting weather along their route of flight. And also, the good news is you're a very optimistic group, all right? You got a good attitude. But what happens is in that, oftentimes you're thinking weather conditions are going to be better than what they actually turn out to be. That's documented in some of the studies that Ian was talking about. So conditions, usually incorrect weather expectations en route, and at the destination. Good information that you can go. The FAA put it out a very nice advisory circular in 2021, a pilot's guide to pre-flight weather briefing to help you with some of these things. There's 2 really good modules, training modules on the FAA safety team's website, faasafety.gov. Just got those listed there, conducting pre-flight self-briefings for VFR pilots, and then one that just came out last year for IFR pilots. Highly recommend those. Take both of them, even if you're not IFR, because there's just good information and it's good to have. I think, and this is just some information there, use a process to self-brief so that you don't fall into the trap of using your perception and having that overrule actually what is out there. Ian, I think I'm going to hand it back over to you now, and he's going to finish this out for us.
Thank you, Danny. So I know the audience is, they're all instructors. So we're not here to tell you how to teach weather to your students. We're just sharing what we have found and hoping that you would take something away from it and maybe incorporate it into your training syllabus. A lot of this information that we're presenting here is you have access to it. For instance, this information that's on here, on this slide, came out of the Risk Management Handbook, and I kind of put a collage together to make sense, to get a point over. So everything starts from pre-flight planning. How you plan a flight, it may not work out the way, but at least you'll have an idea of some of the things that you should look for, right? And like Danny said, one of the things that we found, and we've had a lot of pilots that we interviewed and we talked to, we had them actually fly different scenarios, basically to get a sense of how they think and what they're doing. We had experienced pilots, we had flight instructors too, highly qualified flight instructors, and some of the same behavior we noticed, right? So most of us as human beings, the closer we get to our destination, even when we're driving a car, we tend to push it. So you're going somewhere and it's raining real bad, and you're like 3 miles away from your destination. Most of us are not going to pull over. We're going to say, it's just 3 miles, and so we go. And sometimes we take that same attitude up in the air, and it ends up killing us, right? So it starts from pre-flight. Most of you know about the PAVE tool. If you don't know about it, you can check it out in this handbook. And then the I'm safe checklist, right? So if you're not feeling well, you shouldn't be flying. If you're fatigued, you shouldn't be flying. There's no meeting that's important is worth losing your life, because like I told someone this morning, if you're not around, they're gonna replace you anyway. So it's not worth it. Then you have the risk assessment matrix. And of course, you have the assessment tool on the other side. And then in the middle, I made that one up. That's a generic list, right? You can wait it out, right? You don't have to go. The second bullet there is very important. You can take an IFR pilot with you if the weather is IFR. But that pilot should be current and proficient, because there's a difference between having an IFR rating and being current and proficient. We've had a lot of pilots tell us that when you ask them, do you have an IFR rating? Yes, I do. Are you current? Or when was the last time you flew? Oh, I don't remember. Well, he's not current. You can also cancel the flight, or if your destination is close, you may want to think about driving. The 3 P's, and I like to add some humor into this. For those of you who watch TV, it's not price, 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 okay? It's perceive, process, and perform. This is a decision-making tool, and it's also found in the risk handbook. The first, perceive, we talk about perception. If your perception is incorrect, is obviously the information that you're looking at, you're not going to be able to make sense of it. And so you're going to make wrong decisions based on that. So in summary, Adverse weather remains a major cause of general aviation accidents. Pilot perception of weather is influenced by lack of weather knowledge, past experience, inability to interpret weather displays. And these are just some tips. Understand weather impacts on your flight. So I attended Embry-Riddle Aeronautical University. I did my bachelor's and master's at Embry-Riddle. And my track was aeronautical science. So when you're doing aeronautical science, you have to do aviation meteorology. The way I was taught, it seemed like I was being trained as a meteorologist. And as a pilot myself, I'm concerned about how the weather impacts me and my airplane. I don't care about the science. That's just me. And I need to know the capabilities and limitations of the weather that I'm looking at. And I also need to know the capabilities and limitation of me and my aircraft. And then I can set my personal minimums. You set your personal minimums, which is what you're comfortable with. And if you're in the cockpit and you're using a word, I think, it means you're not sure. You need to stay on the ground. You need to learn how to interpret weather information products. There are many products out there, like I said earlier. You need to understand the strengths and weaknesses of each of them. Verify information using all available sources. You guys know about what's in the AIM, right? You're not just supposed to look at one piece of information. Also need to learn the source of that information, how valuable it is, how valued it is, what type of quality control is done on it. If you're in doubt, find out, right? So if you're not comfortable, a lot of pilots are self-briefing now, and some of them are looking at information and they don't know what they're looking at. We have a study right now that Embry-Riddle Aeronautical University is doing. We should have a report by the end of the year, and we can share it with the public. And we found out that a lot of pilots don't know what they're looking at. And if you don't know what you're looking at, you can't use that information to inform your decision making. Understand the capabilities and limitations of the weather displays. For instance, NextRed, right? A lot of people are using NextRed to actually navigate through weather. I tell people what you see out the window, that's real. What you see on the display, it's got latency. You need to know how latent that information is. The NTSB put out a safety alert based on several accidents where pilots were using NextRed to make decisions. One of the things we're struggling with is that a lot of times when you have a weather-related accidents, we're not aware of what the pilot was using because if they were using a tablet or something like that, that's destroyed in the accident. We would be glad to have that information. Then we can figure out what they were actually using. Now, if they were communicating with ATC or flight service station, yes, there are tapes that we can pull, which NTSB does pull, and we can glean exactly what is it that we're looking at, and so we can figure out, okay, well, maybe this is too complicated for them. Maybe it didn't, explain everything that they need. So we're trying to figure that out and figure those gaps out and try to figure out how to make it more intuitive. Effective decision making is on safety, rely on accurate perception. And I think that's our last slide, and we have about 5 minutes for questions. However, if you have a question, we're in the FAA hangar, please come and see us. And we have some new prototypes that we're working on. We need feedback from you guys. So come see us at the hangar. Thank you. Okay, so the question is what prototypes are you talking about? So the MITRE Corporation has a prototype called Digital Copilot. They were able to give us some of that data, and we're gonna try to do a weather scenario on it, whereby you can set your minimums and stuff like that up on it on that application, and it will actually inform you when there's a change in weather. So we're going to take that and we're going to do a part task simulation first with some pilots to find out how they wanted information to be displayed. Is it beneficial for them? And then we put it in the simulator, write a scenario, have them fly it. One group is not going to have that, the other group is going to have that, and then we're going to see whether it made a benefit. Then we're also using augmented reality and virtual reality to train pilots, right? So in the old days, you have a static image in there. The virtual reality can bring that image to light, and you have a visual. So we're looking at the new generation of pilots who are into apps, right? And a different way of learning. But you can come to our hangar and we can explain some more about what I'm talking about. The FAA hangar, you'll see it where the where the tower is, the safety center. Any more questions? Yes.
Can you speak to the planned continuation error? You were talking about perception versus reality, but the planned continuation error that pilots make, hoping it's going to get better.
Oh, all right. So that's a good question, right? You know, I think it's one of the, I think it's personal preference. You know, you got to do your homework, right? You got to understand weather if you're going to fly. And you have to first realize that weather is dynamic, right? It's not static. If you think weather is static, then you shouldn't be in an airplane. And so you do a proper pre-flight planning. You look at all options. You know, before I plan my flight, or while I'm planning my flight, I look at the route of flight that I'm going to flying. I look at all the alternate airports that are in that area. I look at the services that those airports have, because I don't want to land somewhere and stuck in the boondock, even though I'm safe. But I do my homework. And then, of course, things change, but you have that mental model, at least. You're not behind the learning curve, right? So when something does happen, you know what to do. So pilots have to learn that skill, and sometimes it's not easy. But as instructors, that's where you come in. You know, they may think you're bugging them, but it's going to help them in the long run. Just keep asking them, you know, like you plan a flight to go somewhere. You let them plan the flight. You look at the weather, they look at the weather, and then you ask them, can we go on the flight? If they say yes, then, you know.
So pilots are very goal-driven. They want
they're task-oriented or goal-oriented, right?
Yes,
and the closer you are to the mission, the more you want to push them.
They want to get to their destination. They don't want to disappoint their passengers.
Exactly. And that's called external pressures.
Right.
So if you succumb to external pressures, that's when you're PIC, so you can't blame your passenger if you get in an accident. Yeah, and it's part of the culture. Yes. Any more questions? Yes, sir.
I'll just add to that discussion. An old pilot once told me, and I've never forgotten, it's better to be on the ground wishing you were in the air than in the air wishing you were on the ground.
Exactly. But you know that there's something called get-homeitis that killed a lot of people. You got to be smart. I mean, you know, there's no one can force me to get in an airplane and fly it if I don't want to. I don't care what names you call me. You hear things like, man, you're a pilot. You should be able to fly. This weather looks good. Well, they didn't get the certificate. I have it. So I'm not going to go. All right. Thank you very much. And like I said, if you want to come by our hangar, please do. Thanks.